Hello everybody, good morning, good afternoon, good evening, wherever you are. Or perhaps some people are even working in the middle of the night. I'm delighted to be a very small part of the Development Days of Summer 2024 presentation by Embarcadero. I'm going to talk to you about using Clang with Windows. The Embarcadero C++ builder subset of Rad Studio is an ideal tool for anybody wanting to get the well-known and well-established Clang C++ compiler running conveniently on a Windows platform. In fact, it runs straight out of the box with Rad Studio or C++ Builder. This is me. My name is Roger Swann. I set up Seagull Controls Limited way back in 1981 when I was writing hex code on a entry through a calculator keypad into a Motorola development 8-bit microprocessor development system. I very quickly picked up Ball and Turbo C and went on to be a big fan of the Ball and C++ builder and the Embarcadero Rad Studio products. I use them extensively and still do. They've earned me a reasonable living all these years. And as you can see, I was honoured to be invited to join the Embarcadero MVP scheme, particularly as a C++ enthusiast. You might like to ponder where I got the name Seagull from. I'll reveal that at the end of the presentation. What are we going to talk about? Well, a brief introduction into Clang. Then we'll demonstrate the building a simple Hello World console, because that's what you have to do whenever you're starting with a new language presentation. We'll talk about different versions of compilers that Embarcadero currently issue with their tool. The way you work with GUI, graphic user interface frameworks, the convenience and the ease of adding third-party products to the Embarcadero development system, and also the wide range of third-party components that are available. Then I'll demonstrate building a VCL application, which is a very trivial demonstration because of time limitations, but showing you a GUI application building from scratch. I'll just touch on debugging, show you how this work is built into the IDE, and just touch on VCL styles, which is actually quite a complicated subject, which is how you can quickly change the overall appearance of your application, your Windows application, without affecting its functionality. And then you'll have had quite enough from me by then. It'll be time for some questions and answers, so I'll have a brief conclusion. When C++ was first developed by Bjarne Stroustrup, they very quickly followed many versions of C++ compilers. Lots of companies got on the bandwagon and tried to write their own, or succeeded in writing their own indeed. And Borland was one of them. As the language has evolved, and it continues to evolve, it's become more and more complex. The standards committees got involved, and there became a quite rigorous and time-consuming method of verifying that your C++ compiler was indeed completely compliant with the latest language standards. And because there's a language standard changes quite frequently, this has become a fairly onerous task for compiler developing teams. And now there are much fewer C++ compilers out there that one might choose for a new project. Clang is one of them. Clang is one of the newer ones. It has some novel technology underneath the hood. We're not going to talk really about that today, but it's It's gaining a strong following, a strong reputation for reliability, quality of code, and versions of Clang run on all the major operating systems. But Clang's an open source compiler, and as such its sort of roots were originally in the Linux world. There are ways of getting it running on Windows, of course, but the Embarcadero C++ builder solution is an out-of-the-box solution. You can install the Embarcadero C++ builder and start it up, and you are ready to run a Clang C++ compiler. Embarcadero C++ builder is a subset of RAD Studio, so if you have a RAD Studio license, then the same applies. As you install RAD Studio, straight out of the box you can run Clang. You can compile, build, link, run Clang compiled C++ code. It's that simple. So we ought to prove that it's that simple, and the first thing we're going to do is demonstrate building the Hello World console application. Does anybody write console applications these days? You'd be surprised. I'm sure there are many people out there still doing that, particularly in the control world, in the Internet of Things world, where you don't have a graphical user interface in your application, and the console approach is all you need. In fact, I have a job at the minute where I'm writing a C++ console application using Clang 64-bit under the Embarcadero C++ builder. We're going to demonstrate building this Hello World application without using any of the extra power that comes with the Embarcadero product. So no frameworks, just the bare minimum to run the C++ code with the standard template library, the STL. Okay, let's see it happen. I'm going to create a simple Hello World console application as a simple demonstration. So I'm using RAD Studio 12, and I go to File, New, because I'm creating a new application. It's a whole list of different sorts of application that I can choose from. I'm going to go for Console Application in C++. I'm going to select C++ file. I'm not going to have any target framework. And you'll see that it's created me a skeleton application. And in here, I'm just going to type 2 lines of code, which are the standard C++ Hello World code. And now I'm going to run that. Let's see what happens. Up here, there's a green triangle with a little ladybird next to it. That's the run mode running in debugging mode. It's compiling and linking. And now it's created the shell. And there's the Hello World that we expect to see. I'm going to press a key on the keyboard and the program terminates. Now this is defaulted to producing a Windows 32-bit application. You can see over to the right I have the project tree available. It's just named the project Project 1, and here's File 1, which is the file we're editing. And you'll see that it's part of a project group which is called Project Group 1. I'm going to do a Save All, File Save All, and I'm going to navigate to where I want to save my source code. And I'm going to call the project, give it a meaningful name. I'm going to call it Console Hello World. And now it's going to ask me for the name of this file that I'm going to save, which is the source code file. I'm going to call this conhw main because it's got the main entry point for the program. and you'll see that in the project window now those names have appeared. I think I'll save this project group as well. I'm going to call the project group, and I'm going to give the project group a name of Summer 2024, as I'm part of the Code Gear Festival. Okay, you can see that the build configurations are set to debug. Again, we'll come to that in a minute. And then the target platform is a Windows 32-bit platform. Well, I'm up with the world in terms of being modern, so I'm going to create an up-to-date Windows 64-bit console application. So I'm going to right-click on the target platforms and select Add Platform. And you'll see that there's actually two options for Windows 64-bit. And I'm going to choose Windows 64-bit Modern. We'll have a discussion about the availability of different compilers after this section of the presentation. You'll see there's a checkbox to make this new platform that I've selected active. Okay, so now you can see that I've got Windows 64-bit here as the option. That's the target it's selected, and because this is in the bold, that tells me that it's Windows 64 that's selected. I can build this now. I go to Project, Build Console Hello World. It's doing the compilation again. And that's completed. And now I'm going to run it. And there we go. Hello world again. Okay, so that's how you build Hello World application. And in fact, we demonstrated there with no additional frameworks, using both a 32-bit and a 64-bit compiler. C++ Builder version 12.1, the latest version, actually comes with 4 C++ compilers that target Windows. You might think 4 is a bit excessive, but they're all there for a reason. For 32-bit applications, there's what's known as the classic compiler. This is basically the original Borland C++ compiler that had a great reputation in its time for producing code and compiling very quickly, but it hasn't been supported for quite some time and is really only there for legacy applications. But of course, C++ Builder and Rad Studio have been around for a long time, so there's a lot of legacy code out there that uses classic compiler, and I'm the author of lots of it, and I still support code that's written using the classic compiler, and it all works fine. But it would not be my choice for new projects. It doesn't support any of the newer modern C++ language features. There's also a Clang 32-bit compiler, and if you want to write 32-bit applications for Windows in C++, the Clang compiler is the option you would go for, unless you have a good reason, which is really a legacy code reason for using Classic. With the 64-bit targets, there are 2 versions of the Clang compiler. An older version, which was the one Embarcadero first introduced for creating C++ 64-bit applications, and a much more recent edition, which they are currently calling Clang Modern, which is based on a modern toolchain compatible with our competitors, Embarcadero's competitors, in many ways, and is the sensible choice for any new 64-bit Clang project. The older one is likely to be phased out fairly shortly in favour of encouraging everybody to use the modern version of the Clang compiler. But you currently get both. Interestingly, you select which of the 32-bit classic or Clang compilers you want to use in the project options page, and you select the 64 bits because they're a completely different tool set as a separate target platform rather than in the project options. That doesn't mean much to novices, but there's just two different ways of selecting which compiler that you need to use. I would suggest for anybody writing a new Windows application, they would use the Clang Modern and 64-bit code, which is what the rest of the presentation that I'm offering does. There are two graphical user interface frameworks, both of which work with Windows, and both of which are shipped with all versions of RAD Studio and work straight out of the box. One is called VCL, that's the acronym for Visual Component Library, and is the framework that Borland engineers developed right in the early days of Borland becoming an active vendor in the software market. Wonderful engineering by the original team, and it's continued to evolve and be supported, and it's the framework of choice for modern Windows applications. They also ship the FireMonkey framework, which is a much newer framework developed by the Embarcadero team, and is primarily aimed at the related product Delphi users for multi-device applications. Now, there is the possibility in the future of C++ support for different devices such as Android and iOS and iPhone type devices being introduced, in which case you would choose to use FireMonkey. But for this presentation, we're just talking about Windows targets, and we're going to choose to use the VCL framework. There's a whole vast range of third-party components, applications, add-ins, libraries that all work with the Embarcadero IDE. Some of them are editor and IDE enhancements. Many of them are components that are useful for you to use in design time and run time to get your products completed more quickly. And many of the libraries are established libraries that provide functions that it simply isn't sensible to try and rewrite from scratch when there's years of development gone into an existing library. Some are open source, some come with open source but restrictive licenses, and many are commercial packages, often with a free trial version available. A good deal of these, although not all, are available through the automated installation method, the Get It Package Manager. And this provides a convenient way of actually seeing the wide range of components that are out there, or at least a good subset of that range, and also a very convenient, pain-free way of installing it into your working IDE. One such package is Twine Compile. The modern Clang C++ compiler it's a big beast, and other than projects that are fairly small, once you start getting into realistic size projects, the compile times become significant. And one way of improving the compile time is to make use of your super expensive multi-core PC that you're working on and have many files compiling in parallel at the same time. And there's a third-party add-in, Twine Compile, that achieves just that. You can use C++ builder Clang 64 without Twine compile, but compile times maybe 4, 5, 6 times greater than they are with the Twine compile, and it's a great test for your patience. And if you're a professional developer, it doesn't make sense to be paying developers just to sit there and twiddle their thumbs waiting for the compile to finish. So I'm going to sort of show you how to install Twine compile using the Get It package manager. To use the Get It package manager, you go to Tools, Get It package manager, and you'll see that it's listing some of the many available packages here, and there's various filters that we can apply to help us search for what we may need. In particular, we can click on the C++ section, which will narrow it down to those that are compatible with C++, although many third-party packages are still available or work well with C++, I should say, and we can scroll down. You can see that there's lots and lots of different things available, and it's you can easily waste a whole coffee morning just browsing through here, looking at what amazing things you might use. But we're looking for Twine compile. We type Twine in there, and it brings up the Twine compile. And all I would do is click on Install, and it will install it in. I'm not going to do that because I have already got Twine compile installed, and part of the installation process is that it'll warn you and ask you that it needs to restart the IDE after you've installed it. I know that I've got Twine compile installed because you can see that it appears in the menu up here. But this is a very good example of the convenience of using the Get It package manager. So we've got Twine compile installed. That's good. We're ready to build a 64-bit VCL application using the Clang C++ compiler, all out of the box with the Embarcadero RAD Studio or C++ Builder IDE. Remember, we're not using any additional third-party components in this demonstration. The only third-party thing we've so far installed is Twine compile, just to make the compilation itself comfortably quicker. Okay, let's do it. We're going to create a 64-bit Windows VCL application to demonstrate a typical graphical user interface. I'm going to hide this file from the editor window, and I'm going to create the new project in the same project group. I'm going to right click, and I'm going to select Add New Project, and you'll see there's a range of different C++ Builder project types that I can add, as well as other options. Windows VCL application is actually the one that we're going to choose. The console application we've already demonstrated, and there are various other options. A Windows DLL is one. A package is a Embarcadero structure to allow the transport of components from one user to another very conveniently. We'll select Windows VCL application, and you'll see that it creates a form here, and if I close up the Hello World project, you'll see that it's created a new project in the project group Summer 2024, and in typical Embarcadero C++ Builder fashion, every time it creates something new, it gives it a name, a textual name followed by a number. And you'll see countless demonstrations on YouTube videos where developers continue calling their project Project 1, calling their forms Unit 1, and never bothering to rename anything. I'm not quite the same ilk as that, so I'm going to save my project with a meaningful name. So I'm going to go to File, Save Project As, and I'm going to navigate to the directory where I want to save it, which is in the same directory as previously used. I'm going to call my project VCL Summer. And you'll see it's also going to ask me to save the form that we haven't really looked at yet, the graphical interface form that it's going to be. I'm going to call this VCL Summer, and I'm going to call it main because it is the main form. Main, I'll call it main GUI. Okay, we've got a form. If I click on the form, down the left hand side you can see a whole load of, it's called the Object Inspector, and you see a whole load of properties associated with the form. One is the caption. I'm going to change the caption. This is the text that's going to appear across the top. I'm going to call this C++ demonstration super easy to use graphics. And you'll see I've been typing down here, but the actual form that the user is going to see that we're seeing during the design is updated live as I type. Here's the new caption of the form. This form's got a name, in typical fashion it's called Form 1 under name. I'm going to call this VCL Summer Main. So I've called the form the VCL Summer Main form. And got this far, let's just have a look at what has actually gone on behind the scenes. So here's our project in the project tree of the group project. Here's the form VCL Summer Main, and if I open that up, you can see that the form that we've got on the screen here actually is made up of three parts. It's got a CPP code section, it's got a DFM section, which is actually the representation, contains information that is the representation of the form we can see, and it's got an associated header that we can then include in other C++ source files if we want to gain access to some of the things on this form. Let's have a look at the code. I can look at the code by simply double clicking on the file name here, but equally if you look down here there's a tab labeled with the file name, and this is the code associated with the form we've just created. And if I click on the header tab, there's a header file too. So we've got the usual header exclusion definition at the top. We've got a series of header files that have automatically been included, and these allow the C++ compiler to have access to the VCL items it needs on the form. And then we have a class that represents the main form. You can see it's derived from an internal class provided by the C++ Builder VCL framework. And it's got three sections in here, and all that the only function it's created, or the only function is the constructor for the form. It's got the same name. And then it's created an external declaration of an instance of the form as a pointer. Let's look at the code, and you'll see there's the actual definition, the point where the pointer for the main form is defined, and here is the constructor for the form. So we can actually manually edit this file and add other items in here if we wish to. So let's just do that. Let's add a string. So I'm going to, first we need the header for the string. So I'm going to add in the standard C++ header for an 8-bit string, and I'm going to make a private component. I'm going to call it standard string, and we'll call it text1. No, we'll call it display text. Okay, and we can put that in the constructor. We can initialize that in the constructor list if we wanted to. Let's get the name right. You'll see I'm using the modern C++ constructor format with the curly braces. There's a really good discussion on different initialization formats in the book Effective Modern C++ by Scott Myers. I can't recommend Scott Myers' texts strongly enough. He's a well-known but extremely erudite C++ programmer worth studying. Okay, now I think that would compile without any problems, but wait a minute, our target is still the Windows 32-bit, and remember we want to build a Windows 64-bit platform. So we're going to go over here, we're going to select the Windows 64-bit modern here, and that will make sure we use the latest version of the Clang compiler and create a Windows 64-bit application. We could try running it. Shall we try that? We'll click on the Run button. Now this window down here is Twine Compile. It's building the pre-compiled header first, which it needs for the rest of the compilation. And now it's building the remaining files, and it's found an issue because I've got a semicolon on the end here in the initializer list. Let's build that again. It's linking. And here's our form. We've got nothing on it at the minute, but you can see the caption that we programmed up there, and we can minimize the form, it'll disappear, we can bring it back, and we can close it. Great. Let's add a button and some text. Okay, if we go back to the form view, which is the design tab here, here's the form. You can see that there is in the palette becomes visible, and there's a whole range of visual components that we can add here. Some early ones, they're called Win32 historically, but they still work with the 64-bit application. They're categorized in various ways. There's some that go back to Windows 3.1, but you can still use these if you wish to. There's a whole range of the dialogues, already built dialogues. There's various ways for accessing databases, which is beyond the discussion of this video, that's for certain. And you can see there's things related to the various internet components built in. Indie is a whole set of components designed for communications over the TCP/IP. A T-chart, myself, I use this quite a bit. This is graphing and charting tools, components. Okay, but we just want, what do we want? We want a button. How can you have a form without a button? So there it is, T button. Let's put it there. You'll see it's called it button 1 and it's got a caption button 1. Let's call this change. This is the caption that's going to appear. I'll make the button a bit bigger. I can just drag it to make it a bit bigger. And I'm going to give it a name. Rather than button 1, I'm going to call this the change text button. And if we go back to the header, you'll see that there is now a component of type T button appeared in the published section, the IDE managed section of the components here. And I want to put on the form some text. Well, T-label is one way. T-label provides text without any surrounding box. Let's use a T-label. We'll call it up here. Caption is the text that's going to appear on the screen. We'll just put XXX in there at the minute. We're going to write data to the screen at runtime, and we'll call this display label. Okay, so when we want to change the text in the label when we click the button. With the button, there's all these properties that you can set, but there's also events, and the most common event for a button, there's lots of other events you can click on, but we want to something that will happen when we click the button. And we can just double click. It's created an event handler for us called the change text button click. It's changed to the source code, so we're ready to start typing what we want to do when the button is clicked. And what we want to do is, what I'm going to do is take the value in display text and put it on the screen in the label. Okay, and as soon as we handle text in C++ Builder, we have to open the can of worms of what actually represents text. I've got display text as a variable which is standard string, but the visual components use the inbuilt class string, which is spelt with a capital S, string. And we need to convert from our standard string to the capital string. Now, capital string is Unicode, and it actually is a really good class if you want to use Unicode. There are other C++ Unicode libraries out there, but if you're using Embarcadero VCL or the other Embarcadero framework, the string class does an awful lot, if not all, of the Unicode under the cover stuff that you need. And newcomers to Unicode often make the mistake of underestimating the complexity involved in handling Unicode characters. So I strongly recommend any text that's going to be used for display to the world, i.e. used on a label or as a content on a screen, is converted to the Unicode class. So I'm going to create a temporary variable of type string. I'm going to call it scratch. I have a rule: I never call a temporary variable temp, because I always use temp for temperature, but that's because I'm a control engineer. And I'm going to initialize scratch from the contents of display text, and I have to pass the constructor a pointer to a C string, so I'm using the C string function. And then I'm going to take the label that I've created and set the caption to the contents of Scratch. And to save typing, I can go back to the header file and see that there's the display label name. I'm going to copy that, I'm going to paste that. So I'm going to set the property caption to the value of Scratch. I'm going to save the form. There's a shortcut button up here for save. I'm going to, let's see if this works now. So I'm going to run the form. It's built okay, it's linking. And there's our form. And now if I click this button, change text, the on-click event handler has been called and the text has been changed. Right, let's just talk an introduction to debugging. So here's the on-click event handler where we create a temporary copy of the display text, and then we pass that as a string type with a capital S to the display label caption. I can click in the margin here and create a breakpoint, and I can now run the form again. And now when I click on the change text button, there's a blue arrow here to show that we've broken at this point, and we can inspect values in the property over here. You can see that the value of Scratch is display text as initialized, and we can actually single step. There's 3 buttons here that allow us to single step. This one runs until I can just press the run button and it'll carry on running until it hits the next breakpoint. There isn't another breakpoint, so that's all working well. Let's add a bit of colour to the form. I'm going to go to the form, and now I'm going to scan through the palette to find an image component. Note how I can type a few letters of the component I'm after, and it gives me lots of options that contain the letters I've typed. I want a T image, the simplest perhaps. It's created one on the form by clicking. I can use the handles to make it the size I want. Okay, if we run this, the image will be invisible because we've not done anything to set it up. There's no sign of an image here. Okay, let's go back to the header. We see that the image is there. Oh, I haven't renamed it. That's very lax of me. Let me do that. So I'll select it, find the name and call it display image. Okay, colors. In the VCL, the color is represented by a type of T color. I'm going to have a list of colors, so I'm going to Beyond Strustrup says that if you need a container and you don't know which one to use vector. I use vector a lot. I follow Beyond Strustrup's advice very frequently. He wrote C++ after all. I'm going to declare a constant vector. I'm going to call it colors, and it's going to be a vector of type T color. Notice that the T colour is spelt the American way because that's a built-in class. I have no choice of that, but I'm English, so I'm using colours spelt the English way. What the joys of multinational life. Okay, I can initialize T colours at this point in the header because it's a constant, and I'm going to have red, blue. Okay. These constants that I'm using here are predefined in VCL. They work fine. You can, there's a whole range of colours predefined, or you could define them yourself from hex values. Okay, I'm also going to have an integer, which I'm going to call next colour index. And I'm going to initialize next colour index to 0. Oh. Okay, we need another button. I need to go to the form, look for button, just type BUT, that will get us there. I'm going to put it down here. Okay, now I could make that the same size as that. I could go to the properties and look for width, which is, as you can see here, 97, and look for the property height, which is 49, and I could make this the same, and it would be the same height as that button. Let me show you a trick. If I select and press delete, it disappears. If I select the one that I'm using as my kind of standard button, I can right click and select edit and copy, and now I can open up Notepad, the standard text editor, and I can just paste that text in, and this is the textual representation of the button. Actually, this representation is the way that the button is stored in the DFM file that we talked about earlier. You can see here's the name of the on-click handler, here's the caption, here's the button name. So what I can do is I could change, if I change that to change color, change the name of the button, I can change the caption to change color, and I don't want it to call that on-click. I'm going to auto-create my on-click handler, so I get rid of the old on-click handler. And now I can just copy that text, select it and select copy, go back to the form, right-click and select edit and paste, and here's my new button. And now I can reposition it on the form where I want. And now you can see that the button has got the correct name. Change color button. I can go to the events, I can create an on-click just by double-clicking in the on-click section there, and here's it's created the code for my on-click handler. Now I need a color. I'm going to call it color this, color equals colors, suffix, and the number is next color, the index is next color index. Now I'm going to do next color index. I'm going to increment it, ready for next time. Now I'm going to check that we've not overflowed. Okay, so now I'm checking that I haven't gone past the number of colours that we've got in our list of size, and if we have, we go back to 0, so we keep looping round. Now I need to send that colour to the image. So each image, display image it's called. Yeah. Each image has a canvas, which is where you can display pictures that you might have pre-created, or you can write directly to the canvas. A canvas has a brush, and I want to set that to this colour. No, a brush has a colour, it also has styles and various other things, but colour, that's the American, this colour. And now I want to fill the rectangle, so and the parameter that the fill rectangle function takes is a type T rectangle, which is defined by 4 points, and we want the whole of the available control, so that's 0 for the top left hand corner, and the width. So now I'm going to just drag that across to save typing, and it's got a width property and a height property. Okay, so we basically set the brush to the next colour from the vector, and then we're going to use the fill rectangle function to fill the rectangle which we've set to the whole width of the actual control. So this is quite nice. It demonstrates that we can use a standard vector, which is a C++ STL container, using a VCL class to represent the colour, so that all shows that that all mixes together nicely. Let's run that and we'll see. So I click change colour, there it goes, red, blue, green, and now it should go back to red. Oh, we've got black. Have we got black in the list? No. That's because that should be greater than equal, so there's a bug there. We were lucky we didn't get too severe undefined behaviour there when we rode off the end of the vector. Let's change that to greater than equals, because if it gets to 3 we've gone too far. 10 out of 10 if you spotted that before me. So there we go, now we're cycling round. And now I'm just going to do one final demonstration to show how at runtime you can change lots of other properties. So if we have various controls, so if we want to change the size, when we click the change text button, I'm also going to change the size of the display image. So I'm going to make the width let's just change it to a smaller, and let's run that. I've just made it a much smaller image now. So there's the change colour going through, and now if we click this, see how the square is reduced to 100 by 100, but the fill rectangle will still accommodate that. Okay, this looks all very standard Windows type stuff, and you can see from the palette the range of available components down here is immense, and that's before we've added any third-party components, and there's a huge range of third-party components out there, and it's possible to design your own components and add those in too. But if we want to quickly tart up our application a bit, there's another very powerful feature, which is the overall Windows style. And I can go to the project options, and this brings up various options associated with the application itself. And I can go to application appearance, and then there's a whole list of different styles in here. We're using the default Windows style, but let's pick I don't know this one. Let's try Emerald Light Slate. So all I do is click on that, click Save, rebuild the project. And you can see that the selected button goes yellow. So the actual functionality of the application hasn't changed at all, but the way it just appears to the user hasn't changed. These buttons are different, so you can very quickly introduce neat changes to what you present to your customer base. Just before we move on, here's a short aside. Just briefly, I'd like to show you what you can achieve with VCL and C++ Builder. This is a simulator for a full plant for pressure testing. And you can see we've got some nice graphics representing the source of the pressure we use for pressure testing here, and we can pressure test air valves that are mounted here through 2 different channels, and we can pressure test water valves that are mounted on a different system but driven by the air pressure originally. And all these components you see on the screen are written by us using C++, and then they're installed as C++ components. We haven't really covered that in this very brief introduction, but it's a surprisingly simple technique, and it makes it very easy to reuse different graphics. In effect, you're creating graphics that you could sell as third party, but you're using them yourself. So, and this has quite a lot of inputs and outputs. This is a summary page, so you can see this is quite a powerful system. We've got some sliders up here to represent actual potentiometer values, linear values. So it's as you learn to use all the different features that are available, it's a wonderful coding environment. Okay, so we built a Windows exe using the Clang C++ 64-bit compiler, along with the Embarcadero VCL Visual Component Library framework that ships with the IDE. What have we done in this short presentation? So we've obtained the Embarcadero Rad Studio or the C++ Builder IDE, the development environment. We've started it up and we've gone straight ahead and built C++ code based exe files targeting Windows using the Clang 64-bit compiler without any real tweaking of setting up at all. It works straight out of the box. We used the framework, the VCL framework that comes with the Embarcadero product, to very quickly build a simple but attractive application, and I only used 2 of the wide range of standard VCL components that ship with the Embarcadero product, and indeed none of the myriad of additional VCL components that come from third parties. I also very briefly demonstrated the use of breakpoints for debugging, and there's enough scope in debugging to talk about for a whole presentation. And obviously debugging is a vital part of any code development. In fact, I always say, as an aside, that you can tell a good software engineer because when you ask him or her to do something for you, the first question they ask is, how are they going to test it? Not how are they going to write it. I'm getting off the topic. I also demonstrated the setting of the visual component library component properties at both design time, that's when you're setting them using the development environment, the editor, and also at runtime, where you're changing properties of each of the components under the C++ code control. I showed how the Get It Package Manager can be used to gain access to the many of the wide range of third-party add-ins that are out there, and we didn't have time to browse through and talk about particular ones because there's so many. But we did demonstrate the use of the standard C++ STL containers, the string and the vector, and I did show that the vector, for example, works very seamlessly with all the classes defined in the VCL framework as well. I did give you a very brief glimpse of a working VCL desktop application as well. This built with C++ code and is a product that I've actually developed in the recent times. The whole presentation has avoided the word Delphi. Delphi is the other compiler and product that comes with the RAD Studio, and was indeed the first language to use the VCL framework. The VCL framework is actually all written in Delphi, but as I've shown, you don't need to know that at all to use it very effectively. Over the long time I've been working with Embarcadero products, I have come to be vaguely familiar with the Delphi programming language syntax. It's basically an object-orientated version of the original Pascal language. But I'm a long way from claiming to be even a competent Delphi programmer, and yet I still use the C++ builder part of RAD Studio very effectively. But one of the reasons is because the two run in parallel in most cases without anybody having to make any special effort. So by using C++ builder, you gain access to the whole range of Delphi components, often without even realizing it. It's a great way to get Clang up and running quickly and painlessly. That's about enough, I think. So I did say, why did I choose the name Seagull? Well, the answer is it's logic spelt backwards. And it's always a good test when you're dealing with new customers whether they spot that immediately or whether you have to give them a few hints. Anyway, I've finished my presentation. I'm off to blow my natural French horn, which is another of my hobbies that keeps me sane when I'm not doing programming and development. Thanks for your attention. I hope you've enjoyed at least some of what I've been talking about, and I hope that you find it useful and get out there and use the Clang C++ compiler. Enjoy the rest of your development days of summer 2024 entertainment, education and erudition, either as replays or as further live presentations.
We have Roger with us. Hello, Roger. Let's test your mic because we were not sure whether your mic would work.
Yeah, I'm there.
There you go. I can hear you fine, so that's great. That was a great presentation. Martha says, producer Martha's in the background. She's like, what is happening? recording. I think we all clicked on buttons at the same time and got those things going. So really great. We don't have a massive amount of C++ presentations in these 2 weeks, but we do have some, and this was the first one, and it was a good start. I really enjoyed it. We did have some questions. Let me first of all put your website up here. See, I've learned to point to the logo properly now. I'm almost, that's the one. See, you can even do it. Oh, that's just perfect. But if people scan that QR code, they will go to your website and they can learn more about you and what you do, and logic spelt backwards, Seagull, yeah, Seagull, I think, and also your natural French horn. We were chatting in the background, weren't we, about our history and the fact that I played trombone, and of course we would have been sitting near each other in the orchestra, but not quite next to each other. Yes. So, questions for you. Let me just go to the question section. They always call it chat, which confuses the heck out of me. Right, so the first question is not really a question as such as a comment. And that's from Gary Oginisa. I'm going to really butcher that name. And he just wanted to say, hi, Roger. Great presentation so far on the Clang 64-bit compiler. I need to ask you this, Roger, because as a C++ guy, you probably have the answer, the definitive answer. How do you pronounce Clang? Because I do it both ways. Some people I've heard call it Clang, and others call it Clang. What do you call it?
It's funny you should ask that, because that's one that I actually anticipated. I've always used Clang. And but I did check on Google and the official Clang website, and it does say Clang is the right way. So
okay.
Clang it is, and Clang is how it should be. But I've met many people who call it Clang too, which I guess is the obvious derivation of the name. It's a great tool. Doesn't really matter what you call it. Same as I'm happy to talk to anybody. Doesn't matter what they call me.
Well, you know, I swear I've heard David Millington call it Clang, but he'll probably come and correct me now. Yeah, David's very particular. He'll definitely message me now and say, I have never called it that. Okay. So there was a question that kind of confused us both, but we're going to give it a go anyway, which is, when working in Rad Studio, is it possible to run both C++ and Delphi 12, or is it only one or the other that can be run together, meaning both can't run together in Rad Studio? I'm going to answer my bit, and then you can answer a little bit more, because you did say at the end of the video, you know, you've run into Delphi the same way that I bump into C++ quite a lot, but being a primarily Delphi guy. Now, for the people that ask that question, it depends on if you're using the CE edition. Okay, the CE edition is the free version. It's intended for students, and it's intended for startups and hobbyists. So people that are not earning a living day in, day out writing C++ code or Delphi code. If you have the CE version, it is either Delphi or it is C++. You can't have both. It installs a version of Rad Studio, and that version of Rad Studio has either the Delphi or the C++ personality, as we call it. If you install the full version of Rad Studio, so you purchase it or you install trial, then you get both, unless you purchase the Delphi only version or C++ version. But if you choose Rad Studio, then you get both. And so the answer is, can you have both in the same IDE? Yes, you could open a Delphi project and work on a Delphi project, close that and open a C++ project and work on that. However, as the C++ programmer, you did mention being able to consume Delphi code. If you want to just speak to that for a minute, I know you said you're not a super expert on it, but
yeah, the first thing that's slightly confusing is that when you install C++ Builder, either the commercial product or the CE version, the Delphi compiler does come along under the hood, because the VCL and indeed the FireMonkey is almost entirely written in Delphi. So when you write a VCL application, as I did in the simple example in the video you've just watched, underneath the hood there is a Delphi compilation going on. But when you just buy C++ Builder, or you just use the community edition of C++ Builder, you don't gain access to Delphi yourself. So you can't write a Delphi project. You can't create a component using Delphi. All you can do is actually what I showed you in the video. You can write C++ code. You can use the VCL components, and both visual components and also the built-in other components such as the Delphi, the string type with the Unicode string. So that's the disadvantage of limiting yourself to the C++ Community Edition or the commercial version of C++. When I first started in this game, the first C++ product I had was just C++ Builder, and it was only quite a long time after I purchased that. We're going back into the late 1980s now, hence the grey hair. It was only sometime after that I realised, having to dig deep, that Delphi was indeed happening in the background.
Right.
So when you have the RAD Studio, where you have both C++ and Delphi enabled, as it were, when you start a new project, you specify whether it's going to be a Delphi project or a C++ project. But there are various ways that you can handle code written in Delphi code written in Delphi is a better phrase, written from your C++ program, or indeed you can call C++ program some code, provided you follow various rules from your Delphi programs. So right. if you've got code that you particularly want to get access to, that's written in the opposite family to which you started your main project, in many cases there are ways to do that, and one of the easiest is actually the component development, which we didn't cover because of the time limit. It's a big topic, but I did briefly mention that I've got a whole set of visual components that I've written in C++ that I keep reusing in different projects, and in many cases for different customers. But it is possible for a Delphi user to come along and use those components. And actually, the Delphi person wouldn't have to know anything about the C++ language to use it. Right. They just use the interface. So that's one of the ways that you can achieve mixing the two. But it's rare. Well, you're getting into specialized areas when you need to mix the two explicitly.
Yeah, I mean, I actually know one of the games developers is an MVP as well, and he does use both. And I can't remember why he was. I think he was just a really big fan of Delphi, but he does C++ stuff as well. And he was raving over the Clang compiler and said, "Oh, this is brilliant," and stuff like that. If you so this is a slightly different question. It's my own question rather than one from the audience. If you were to give as I said to Richard Hathaway earlier on, an elevator pitch. So you get in the elevator and someone goes, here's a question. You're going up to the 23rd floor. You've got that length of time to answer the question. What would your elevator pitch be for people to start using Clang (modern) over the previous compiler? What would be the things where you say, well, this is really, here's a bottled set of reasons to use the Clang modern over something else? Or maybe you don't have a reason, you just say, hey, it's more modern.
No, well, the short answer to that would be go to the Clang website and look at all the developments of each of the editions. But the key change that Embarcadero have done with this, what they're calling the modern version, is the actual toolchain behind the behind the scenes. So again, for somebody who is just starting out, that's a detail that the convenience of which doesn't become apparent until you start to develop as your needs increase, if you like. But the latest tool chain is using industry standard formats for the debugging data and for the linker, which allows you to interact with many more C++ libraries out there, compatibility, if you like, long-term compatibility. So if you're going to start a new project, why would you want to use anything but the most up-to-date version of Clang? There can't be an answer to that. There can't be a sensible answer other than to go modern. But it's only if you've got legacy products and they're working just fine, there may be some advantages actually in migrating across straight away, because my experience so far is that the linker is much more responsive, and so that's an immediate benefit, that the linker works more quickly and saves you time. There are reports that it also handles large projects much better. Although I have to own up that I'm not one of the people who had difficulties with the previous linker that. The new tool chain. Okay, we probably reached 23rd floor by now.
That's fine. Yeah, we're holding the elevator doors open, that's what it is. Okay. Shut button depends on who's outside, right?
Yeah.
So I mean, that's great. I think your presentation is very thorough, and I like that as well. And it was good to actually see your own app as well. Not a lot of people presenting show their actual app, and their real code doing stuff. So
okay, well, let me just. It was quite interesting because I work for industrial customers, and they're very cautious about competitors getting hold of data. But that bit was actually the simulator that I built to simulate the plant, that the other code of which is actually the testing. And you got some nice pictures of the graphics, and I didn't have time to set up showing the simulated changing colors and the tank levels going up and down, which it does do as pressures increase and gases and waters flow. But I think it's interesting that the fact that I had quite an attractive graphical thing built up there, I must have had that fairly easy, because that was only the simulator. You should see the customer's screen, which is sort of designed to make Star Trek look a bit trivial, and the customer's very pleased. And I've now got to the position where if the customer has a problem or they wonder how they can control a particular valve, I change the simulator a little bit and try and replicate the problem and then offer a solution. And that works quite well. But the key thing is I can put those graphical things together.
Yeah,
in a very short period of time. Once I develop the components that I already have.
Yeah, I mean, I'm a big fan of component-based development, obviously, and I keep saying to people, this is the secret. It's object orientation manifest. It is the whole point of it is encapsulation of some functionality, and it depends whether you use your own components or you use ready-made ones. But if you're using ready-made ones, you've got the advantage of thousands of people testing that functionality, which has got to be a good thing, because sooner or later the bugs get worked out and eased out, and if it's your own code, I mean, if you get a lot of people playing with it and you're very thorough in the way you write code, you can test it and make sure it's functional. It's more tailored. It's like going out for a meal and getting a good cook to cook for you, or going at home and you can cook it exactly the way you like. And
and actually, I will be honest with you, there's a lot of advantages in using the third-party items that are out there, and as I've said in the video, installing them through the Get It package manager is usually a couple of clicks and it's done. My components are actually rather trivial, which means the testing is easy, and the reason they're trivial is actually because they're just convenient graphics, and they don't actually do very much other than change color, change size. You can change the size by just dragging the as you place them on the form. The valves change, the colors change. They're very difficult to write that, and it's very easy to test it. And frankly, if there was a bug in there, the only problem would be the wrong color. So I do like the fact that nobody else has a valve exactly like mine. Even though there's thousands of valves out there that all look pretty much the same.
Yeah, I mean, I've created my own components for the same reason, and it is nice to be able to say that's mine. That how that looks, how it behaves, that's me, and that is a kind of a good thing to be able to say as well.
And there is one other very minor advantage. It's not normally a problem, but when a new version comes out, if there is a change in the way the component builds, sometimes you have to wait a few weeks before the third party catches up. Whereas I can just rebuild. I mean, that's one of the disadvantages actually, is that each time a new version comes out, you do have to rebuild all your components. But I've got that automated. So there's swings and roundabouts, and but the key thing is you've got both options, so you choose what works for you.
Yeah. Well, as a company, we believe Clang is the future, and we've pretty much stated that publicly, and that's where we're heading. So, the modern compiler for Clang is the way forward. So, it's someone saying Ultra Edit is great. You're in the wrong session, but yes, it is great. Very much so. Confused me. I'm like, did we?
Although I would actually say that the IDE editor, it depends what you get used to, but I love the IDE editor. And use it all the time. So, and I use it for, I do some 8-bit C language programming for little microchip type size things, washing machines and stuff like that. And I do tend to do most of the editing in the Embarcadero IDE, and then just open the file again in the primitive IDE that comes with the little C compiler. So.
Yeah, and I'm the same with the Arduino stuff and things like that as well. You're coding C++ in there, and I like Arduinos. They're great. It's a brilliant idea, and you can do some crazy. You can't see because of my green screen effect, but behind me there's a whole bench of stuff that does weird things like temperature controls and relays and barcode. I mean, I've done some webinars there. Okay, well, we ran over. We said, I warned Dion that we would be, which is fine. But thanks again, Roger. I don't think you've got another session coming, have you? This is the only one you're doing. Yeah. Okay. Well, thanks for contributing. It's not the first time you and I have been on together. Before we've talked about trombones and French horns and things in the past, as we do. And two Brits together, you're going to get us talking nonsense. That's the way it works, isn't it? It's part of the British way of life, is banter, as they say.
Well, we did quite well to not talk about the weather.
Yeah, well, don't even go there. 42 centigrade it's going to be here today. So can you imagine? Luckily, I have air conditioning, so I'm actually a little bit chilly.
And I am, maybe people don't know, but I'm here in England where it's just pleasant at the minute.
Pleasant, yes, exactly. Well, look, thanks very much for spending your time. I say this to everybody: for every hour that someone sees a video there, it's a lot more work on top to get it right, to prepare for it, to do the slides and all the rest of it. And I really appreciate your time. And I'm sure we'll bump into each other again in the future. All right.
Thanks to everybody out there who was listening. Good to have your attention. Okay.
Oh yeah, there's several hundred live and lots of them on replay. Thanks a lot.